equations, it's going to review how to do both one-step and two-step equations that you learned last year. All right, so let's start with the properties that are going to be important for doing this. We have the inverse property of multiplication and the multiplication property of equality. So starting with the inverse property of multiplication, all that says is anytime you have reciprocals, so for example, 4/5, its reciprocal is 5/4. If I multiply them, I'm always going to get 1. The reason is, if you think about it, 4 times 5 is 20, 5 times 4 is also 20, 20 over 20 is 1. Or you could do your simplifying, how we normally end up doing. All of them get simplify down to 1. Another example would be 8. The reciprocal of 8 is 1 over 8. Again, all of that's going to simplify down to 1. So, multiplying reciprocals always equals 1. So that's the multiplication property of inverse property of multiplication. Then the multiplication property of equality. Any of the equality properties, all they say is if you do something to one side of an equation, you have to do it to another. So in this case, it's multiplying. So if I have 5x equals 10, if I multiply this side by 1 over 5, I also have to do this side by 1 over 5. Okay? So this is that equality property right there, doing it to both sides of the equation. The reason I have to do that is to keep that equation balanced. Those two sides are equal. If I change something on one side, I have to do the same change to the other to keep that balanced scale. So whatever I do to one side, do the same to the other. Alright, so that's the two properties we're going to start with. And so let's look at some of these equations and review how to solve them. So starting with this one, we got 4x equals 59. So the goal in any time you're solving is to isolate the variable. In this case, the variable is x. And the way we need to isolate is to get rid of that 4. Now, if I can make the coefficient 1, the coefficient's 4. If I can make it 1, that's isolated. 1x is just x. So, how can I make it 1? Well, we just said that if I multiply a number, 4, by its reciprocal, 1 over 4, that will always equal 1. 4 times 1 over 4 equals 1. And 1x is just another way of saying x. That right there is another property. Let's review that real quick. This is an example of the identity property of multiplication. 1 times anything is just that number. In this case, we're talking about x. Okay? So we already used the inverse property and the identity property. The inverse was right here. There's our inverse property of multiplication. And then we've done everything on one side. We've isolated the x. The problem is we haven't done the same thing to the other side. Remember that equality property. If I multiply the left side by 1/4, I need to also multiply that right side by 1/4. So there's my equality property right there. Okay? Equality. Alright, so I have x on the left side. On the right side, 59 over 4. That's not going to divide in evenly, so you can just leave that as 59 over 4. That's just fine. You can make a mixed number if you want, but you don't have to. You can make a decimal if you want, but you don't have to. In this example, you notice I wrote the 1x. You don't have to write the 1x on yours. I only showed that to really emphasize what is going on and how we isolated that variable by making the coefficient 1. Now remember, the coefficient is that number in front of the variable, that 4 in this case. So we made it go from 4 to 1, which in essence isolates that variable. All right, so let's try another one without worrying so much about the properties, writing them down, and just solving it. So here's another one. We have x over 11 equals 20. So we need to get rid of that 11. You can also think of this as 1/11 x equals 20. That's the same thing as x over 11. 1/11 x over 11, same thing. So what that means I'm going to multiply both sides by is 11 over 1. Do you see how by doing that, those 11s are going to cancel out? The 11 and the 11 are both going to become 1s, which leaves that x isolated. Okay? And I also want to multiply the other side by 11 over 1, which is really just like multiplying 20 and 11. And I get 220 as my answer. So our whole goal is to isolate that variable, make the coefficient 1, and that makes it isolated. All right, so this is actually just like the last one, it's just written differently. X divided by negative 9. The first thing I would do is rewrite this as x over negative 9. Remember that this fraction bar here means division. Okay? So this is an easier way to write it, I think, just because you can really see what's going on and you realize this is the exact same problem we just did. So just like last time, I'm going to erase this means division part so we can do our problem. So just like last time, I'm going to multiply this by negative 9 over 1. So those negative 9s cancel out. Multiply it by negative 9 over 1 on this side. Got to keep it balanced. So my x is going to equal, so they're both negative. 15 and 9 are both negative, so they're going to cancel out the negatives. And then just do 15 times 9. And I get 135 as my x. All right, let's try another one. Go ahead and try this one on your own. It's negative 8x equals 22. Pause the video and then hit play to get the answer. All right, so let's see what you would do on this one. So to get the negative 8 to be 1, I would multiply it by 1 over negative 8. Those will cancel out. Do the same thing on the other side. I can simplify this a little bit. They're both divisible by 2, so I have negative 4 and 11. So my x would equal negative 11 over 4. Now remember that negative, as long as one of them's negative, you see the 4 was negative, that makes my whole answer negative. If they're both negative, they're going to cancel out, which wasn't the case in this example, but that one negative in the 4 makes my whole answer negative. You can leave it as negative 11 over 4. If you really like to make it into a mixed number, you can do that. Up to you, or you can make it a decimal, but any of these answers are fine. All right, go ahead and pause the video and try this one on your own, and then hit play to get the answer. All right, so this one, same thing we keep doing. Our coefficient this time is 5/8. Just because the coefficient is a fraction, nothing is changing. Our reciprocal is 8 over 5, so I can cross all that out. Do the same thing on the other side, 8 over 5. This can simplify down some, 1 and 2. So that leaves my x as 2/5. Now, I know these are one step and they're pretty easy, but you need to practice showing these steps. As the problems get harder, you're going to need to know how to show all your steps, and it's going to be harder to do in your head. So even though these are one-step problems and they're easy, I want you to be writing all of these out. All right, so we're going to go to the addition problems. So first, let's review these two properties. Just like in multiplication, there's an inverse and equality property, same for addition. Okay? The inverse property of addition is a little different. It's not reciprocals, it's opposite numbers. So opposite numbers are a positive and a negative number. And anytime we add them, we're always going to get 0. Right? If I have 8 positive and 8 negative, altogether that's nothing. They're going to cancel each other out. So inverse property of addition is adding opposite numbers always equals 0, no matter what they are. Okay? Even if they're positive a half and negative a half, or positive 0.762 and negative 0.762. It's always going to equal 0 if you add them up. Now the addition property of equality is just like the multiplication property of equality. If we have a problem and I add something on one side, so if I add negative 5 here, I have to add negative 5 over here to keep that scale balanced, okay? Keep the equation balanced. So same thing, whatever I do to one side, I have to do to the other. So whatever I do to one side, also do to the other. All right, so let's practice some of these equations with the addition. So this is x plus 12 equals 99. Again, the 12 here is the add-in. It's the number being added to the x. Okay, so it's the add-in of x. And we want that to become 0 because if x is being added to 0, it's isolated, right? We're isolating the variable. So if I add negative 12, just like my inverse property of addition, there's my inverse property of addition right there. Inverse property of addition. That's going to equal 0. So x plus 0 is just x. Just like in multiplication, this is an example of the identity property. Okay? In multiplication, it was multiplied by 1, doesn't change it. Well, in this case, it's adding 0, doesn't change it. So that's the identity property of addition. Okay, so I've isolated my x. Now all I have to do is do the equality property over here. So here's equality. Evening it out and figure out what that equals. 99 plus negative 12. Well, the 99 is bigger. How much is it bigger by? It's bigger by 87. So my answer is 87. All right, so let's try another one. All right, this time there's subtraction. Again, these are one step. So it seems silly to do this, but we're going to make this plus a negative. So anytime we have subtraction, that didn't write very evenly. Let's try it again. Plus a negative. It seems silly to rewrite it like this, but when we get to bigger problems, getting rid of subtraction is going to make your life a lot easier. So I think it's a good idea just to get in that habit. So since that's plus negative 8, the opposite of that would be positive 8. So add 8. That becomes 0. Add 8 to this side, equality property. So x equals 38. Easy enough. All right, let's try another one. So go ahead and pause it and try this one on your own. All right, so on this one, the first step I would do is make that plus negative. So that means I'm adding positive 12 to both sides. So my x equals 34. Easy enough. You should be hopefully remembering all this from last year. All right, x plus 10 equals negative 5. So I'm going to add the opposite to both sides. And I get x equals negative 15 because they're both negative, so they're going to add up to a bigger negative, negative 15. All right, so we got our one step down. Now let's go into the two-step. The main thing with two-step is just you're doing the exact same steps, it's just knowing what order to do them in. So if I have a problem, 3x plus 8 equals 20, for example, the first step is always going to be adding the opposite. So I'm going to add the opposite of the add-in, add negative 8 to cancel out that 8, add negative 8 to this side. So on the right side, all I have left is 12. On the left side, I have 3x left. So now I need to get rid of the 3. So now I do my reciprocal. It's worked out quite nice. So my x equals 4. Okay? So the main thing to know is that you're adding the opposite first, and then you're doing the reciprocal. Other than that, it's the exact same steps. You're just doing 2 of them instead of 1 of them. So let's try another one of those. So this time, if I have 7 minus 2x equals negative 5. So I have a minus there. I'm going to change that to plus a negative 2x, okay? That's a very helpful thing to do to avoid making mistakes. Add the opposite of the 7. Add the opposite of the 7. So I have negative 12 equals negative 2x. Now I'm going to do the reciprocal. 1 over negative 2. So those cancel out. 1 over negative 2. Those negatives are going to cancel out. And I get 6. The negatives are probably the biggest thing people forget or mess up on. Just watch out for those negatives. Don't forget about them. Double check them. Okay? All right, that's about it with the 1 and 2 step problems. Let me give you one more 2-step just to practice it, and then we'll be done. So I'm going to let you try this one on your own. We have negative 10 minus 3x equals negative 2. So go ahead and pause it and try it on your own and then hit play. All right, so the first thing I would do on this one is change that to plus a negative. And then I'm going to add 10 to this side to make that go away. Add 10 to this side. So this would be 8 because the positive is bigger and it's bigger by 8. And that equals my negative 3x. And I'm going to do my reciprocal. All right, in this case, 3 doesn't go into 8. So I'm just going to leave it as an improper fraction, -8/3. And that's just fine. If you want to make it a mixed number or a decimal, that's also fine. But this answer is perfectly good too, and it's less work you have to do. All right, that's it.